Hello, everyone. Today, we're going to talk about a very important topic in science. You see, our medicines, like antibiotics, are becoming less effective against some bacteria, so we need new ways to fight them. One of the most promising solutions is something called antibacterial enzymes. In this session, we will learn exactly what they are and why they are so important. So, here is our plan for today. First, we will start with the basics. What are these antibacterial enzymes? Then we will learn about the main types. After that, we will see how we can make these enzymes even stronger. Then, we will look at where they're used in real life. And finally, we will cover the important points that you must remember for your exams. Okay, let's begin with the first section. We need to build a good foundation. So, what are antibacterial enzymes? Now, to understand why these enzymes are so important, we have to understand a big problem. For many years, we have used antibiotics to fight bacteria. But now, many of these antibiotics are losing their power. The bacteria are changing and becoming stronger. We call these strong bacteria superbugs. So the big question is, how can we fight these superbugs? And here is a possible answer: antibacterial enzymes. So let's look at the definition. An antibacterial enzyme is a natural protein. Think of it like a tiny natural weapon. Its job is to stop bacteria. How does it do this? Well, it attacks the bacteria's defenses, like their outer wall, which is called the cell wall, or it can attack the sticky layer bacteria create to protect themselves, which is called a biofilm. Okay, so we now know what they are, but you should know that not all of these enzymes work in the same way. So for a better understanding, we can classify them into different types based on how they attack the bacteria. There are two main classes, or types, that we should know. The first type is called oxidoreductases. These enzymes have an indirect way of attacking. They produce harmful things, like hydrogen peroxide, right near the bacteria, and this is what kills the bacteria. The second type is called hydrolases. These enzymes attack directly. They are like a demolition team. They go and break down the bacteria's structures, like the cell wall. A very good example of this is lysozyme. Now let's look at some common examples of hydrolases, the direct attackers. First, we have lysozyme. Remember, lysozyme breaks down the bacterial cell walls. Then there are amylase and pectinase. These are very good at destroying that sticky protective biofilm. Then we have proteases. Proteases attack the proteins inside the biofilm. And finally, there are endolysins. These are very, very powerful enzymes that attack the cell walls. And if you look here, you can see what these enzymes look like. You see, they are not simple shapes. They are very complex proteins. Each enzyme has a unique 3D shape, and this specific shape is what allows it to attach to the bacteria and destroy it. It's almost like a specific key that fits into a specific lock. So we know these enzymes are powerful, but is there a way to make them even more powerful? The answer is yes. And we do this by using them in combinations. Let's see how. The main idea here is teamwork. When we combine an enzyme with another substance, like an antibiotic, their combined power is much greater than their individual power. This is a very important concept. It is called a synergistic effect. Please remember this term, synergistic effect. This table gives us some great examples of this synergistic effect. Look at the first one. We can combine the enzyme lysozyme with an antibiotic called nisin. Together, they can destroy the bacterial cell wall much more effectively. Or look at another example. We can use the enzyme alpha amylase to clear away the biofilm. Once the biofilm is gone, silver nanoparticles can easily go in and kill the bacteria. It's like a 1-2 punch strategy. Now, all this science is very interesting, but you might be asking, where do we actually use these enzymes in our day-to-day world? So let's look at some real-world applications. The really amazing thing is that we can add these enzymes to many different materials. And when we do that, we give those materials a special power, the power to fight bacteria. This opens up so many possibilities. So, where are they used? For example, they are used in antibacterial dressings to help wounds heal faster and prevent infections. They are put into cloth to make self-disinfecting fabrics for hospitals. They are used to coat medical devices to keep them clean. They're even used in food packaging to keep food from spoiling. As you can see, the uses are everywhere, from medicine to keeping our water clean. All right, we have learned a lot. Now, let's focus on the most important points that you need to remember for your exams. Let's summarize the key takeaways. Okay, exam point number 1. Remember that enzymes are biocatalysts. Their main job is to find and destroy the important defenses of bacteria, especially the cell wall. Exam point number 2. A very important function of these enzymes is to destroy biofilms. Remember, biofilms are those protective shields that bacteria use to hide and become resistant. Exam point number 3. This is about that special term we learned. Combining enzymes with other things like antibiotics creates a synergistic effect. This just means that together they are much, much more powerful. And finally, exam point number 4. You must remember the 2 main classes of these enzymes. They are oxidoreductases, which attack indirectly, and hydrolases, which attack directly. So, to finish, I want to leave you with one final thought. As our old antibiotics stop working against superbugs, we need new weapons. So, let's think about this question. Could these natural and powerful enzymes be our best new weapon in this very important fight? Thank you for listening today.